Hello students, so I'm Vikas Agarwal and we are here to discuss KVPY essay paper of 2020 physics section part 2. So we are looking at the fifth question of part 2. Let's see what the question says. So we have a small coin fixed at the center of the base of an empty cylindrical steel container having R as 1 meter. Height is given at t equal to 0. The container starts getting filled with water without disturbing the coin. Approximate time when the coin will be first seen by the observer from O. So this height h is given, L is given, h is here, L is here. Okay, refractive index is here. So let's see what we have to do. So in this question, what is happening? Okay, yeah, I was looking for this space to solve. So what is happening is this. Let's say this is a container. Okay, and there is a coin here. Okay, so when we start filling some liquid in it, let's say after the liquid has reached this certain level, a ray of light which will probably go like this will then start traveling like this to this point, and we have been given this distance as L, we have been given this distance as capital H, we have been given this height as D and this as R. Okay, now what we have to understand here is that if this angle is angle of incidence, this angle is angle of refraction. Okay, this angle will also be angle of refraction, and based on this we can write the equation. For example, I can write tan of r. Tan of r can be written as this length, which is like L minus r. L is given to us, R is given to us, divided by H minus D. Again, H is given to us and D is given to us. So that means I can find the numerical value of R. Okay. Now this can also be written as let's say this distance is X. So we can write it as R minus X divided by this distance. Okay, and this distance would be, if this is h, so we can write it as d minus h. So in writing tan r like this, we have two unknowns, x and r. Okay, so let me put the values here. L was 1.5, R was 1. So L minus R is 0.5. And then H minus D. So H is this, and where is the value of D? The value of D is 4. So difference is 1.75. Okay, so 1.75. So if I solve it, it will become 50 upon 175, which is like 2 divided by 7. Okay, so tan r is 2 divided by 7. So we can find the value of sine r also. The sine r would be 2 divided by root of 7 square plus 2 square. So that would be 2 divided by root of 53, I suppose. Okay, so that is sine r. Now using this we can also find the value of sine I, because we can write n times of sine I is equals to sine r. So n is 1.33, which is 4 by 3. Sine I is equals to sine r, which is 2 by root 53. So from here we will get the value of sine I as uh, 3 divided by 2 root 53. So once we get the value of sine I, we can then find the value of tan I. So tan I would be, it would be 3 divided by root of square of this. So square of this would be 4 into 53. Okay, minus 9. That is square of this. Okay, because if this angle is considered I, then sine I would be 3 divided by this length. So when we are calculating tan I, it would be 3 divided by this length, which is square of hypotenuse minus, yeah, so everything is fine. So it would be 3 divided by root of, this is like 212. 212 minus 9 is 203. So we get the value of tan I. Okay, we get the value of tan I, and tan I can also be written as, tan I can also be written as x divided by h. Okay. So we have one relation between x and h from here, and we have another relation between x and h from here. So using these two, we can solve for the value of h and x both. Once we get the value of h, what remains to be done is this, like I'll use the space here, like pi r square h is the volume of water, and we need to write this volume equal to the volume flow rate, which is zero point 0.1 into this into the time taken, and from here we are going to get the value of time. So guys, I'm leaving the calculation up to you because it's pretty simple now. You can finish this calculation. We will get the value of x and h by solving these two equations. Once you get the value of h, you can put it here, and from there you can get the value of t. All right, so the calculations have been depicted here, and 63 is the closest option that we are getting. So that would be the correct answer. I hope you understood the solution, guys. Thank you for watching it, and stay tuned for the next question.